Hello YouTube. So today I have some different thought in my mind. One of the subscriber asked me to, teach him some data structure because he was entering the college, for the first year of engineering, and he want to learn some data structures. And let's then I okay, then I will do it now. So I'm deciding to, have a playlist on data structures in Python particularly because there are many sources in which you can get these tutorials regarding this linked list, binary trees, and all these data structures in C or C++. But there are many less resources when these things coming to the Python, and that's very valid because these data structures are actually must be implemented in a in C or C++ in the industry scenario or in practical scenario. But the most of the time we are going to for interviews, we want some language that is very easy to type, and it is very not complicated, not too wordy language. C++, typing in C++, you just have to declare too much stuff, class and all that, structures and pointers and all that mess. Okay, so some students find it very difficult to learn data structures in those C and C++ languages. So I have thought that I should create playlist to teach data structures in Python in easy way. Okay, that's the sole motive of this tutorial. I'm not I'm not comparing C and Python. Okay, C is the best language and Python is also the best language, but the roles of the both languages are kind of different. C is kind of we have to learn its syntax, and Python is easy to pick up. Its learning curve is so less. So I'm going to make the data structure videos in Python. So let's go on, guys. Okay, so let's go. So I have this Geeks for Geeks article opened here. First I will tell you the difference why we need linked list in the first place. Okay, so this is a you are seeing this is the most popular data structure. Okay, this is known as array, and each element of array is one after the other. Okay, so this is called contiguous memory allocation. Okay, so let's say this is a computer memory, and the computer memory starts from 200, and sorry, computers memories, this is a this is snapshot of computer memory. Okay, computer memory can extend to this direction and also extend to this direction, but compiler kind of assigned our array from 200 to 206. Okay, so memory can extend to this direction and this direction, but compiler have given us this particular 6 locations. Okay, 7 locations, and you can see that each location is one after the other. Okay, so the main thing of the array is that when you know the base address of the array, that is, if you know that first element of the array, which is u at the 200 location, and the size of u is 1 byte, then I can say that give me this fourth element. So what you will do, that you will just add 4 to it. So you will go 1 2 3 4. So it will give you this a. Okay, so because of this contiguous memory allocation, and because we know the base address of the array, array indexing will fetch the value in constant time. Okay, that's the whole crux of the array data structure. Okay, so let's say I want fifth guy, so I will just go I want fifth guy, so I will just go here. How? So the computer will just calculate like this: 1 2 3 4 5. Okay, this is character data. Okay, so the character data is of 1 byte, but if you have store integer, then it will be like 4 bytes. Okay, if you are using 32-bit, and I guess 8 bytes if you are using 64-bit version, because then it will be like, for this location will be 8 byte. So this 8 bytes, are are arranged one after the other. Okay, let's say that this first integer here, I want the fourth integer in a array, so it will skip this 32. It will, let's say that our integer is 8 byte. Okay, we are using 64-bit, and which is, the standard of this era. So it will just skip this 8 byte, it will skip this 8 byte, it will skip this 8 byte, it will skip this 8 byte, and it will go here. So whatever the size doesn't matter. Okay, in Python we actually don't care, because in C you care actually, 8-bit, 32-bit, but Python is, just remember that the things are arranged in uh, contiguous manner, and if you know the base address, you can go to the any location. That's the crux of the array, and all you know about the array is this thing. Okay, now let's come to the linked list. Okay, the main difference of the linked list, that this structure, it's a very dynamic structure. So this a can be at 200, and this a can be at 200, and this b can be at any location, let's say 600. Okay, that is it doesn't need to be in a contiguous allocation. So since it is not contiguously allocated, a must store the address of the b. If we don't store address of the b, then you cannot go to the b. Okay, so let me open our paint, and I will give you some crude diagrams. Please bear with me, guys. I will just try my best to, understand you. So let's say this is my memory, and this is first location, and this is second location, and this is third location, and this is fourth location. Okay, so in the case of linked list, that this first node can be here. Okay, the first node can be here. Okay, not here. Okay, I will choose here directly. Okay, so the first node can be here. Okay, yeah, first node can be here, the second value can be here, second value can be here, third value can be here. Okay, come on, fourth, and 5 will be here. Okay, 5 will be here, and 6 is here. Okay, these positions are random, but this 2 can point 3. Okay, crude drawing, sorry. So 2 can point 3, 3 will point 4, 4 will point 5, and 5 will point 6. Okay, that will give you this structure. Okay, I will just draw this. कितने 1 2 3 4 5. Okay, ये 3 हो गए यहाँ भाई, और this will be the fourth, and this will be the 5. Okay, please consider that here lives a 2. Okay guys, here lives a 3. Okay, and here lives a 4, and here lives 5. Sorry for my very crude diagram. Okay, but the concept is the same. So this scenario can be depicted in like this. Okay, 2 will point to 3, 3 will point to 4, 4 will point to 5, and 5 will point to 6. So this, this blocks, this can be at address 100. Okay, and this can be at address some 4000. Okay, it doesn't matter actually, it can be anywhere in memory, but since you have links, so since you have links connecting them, you won't get any difficulties to traverse the whole linked list. The thing you have to remember is the base address of this. If you know the base address of this, then by accessing this, the this field which holds the address of the next location, you will go to the next location. So you will do same, you just fetch the data from here, and this location will contain address of the next location, so you will go to the next location. So like this it will does, and this last node, no, it will store the value null. Okay, it will store the value none. Okay, let me type that here. Sorry for a crude drawing of mine. Okay. So it will store this value none. Then please understand that this value is here. Okay, this none is here. So this last node is pointing to the nothing, so this mark the end of the linked list. So I guess you understand this crude diagram. Okay, and so let's go to the coding. Actually, there is this my code school, you can watch their tutorial, but they teach you in C or C++. So for the basic understanding you can watch their videos, and if you want to code in Python you can come to these tutorials, but whatever I explained, pretty much they will explain like this. Okay, so let's go ahead and just code this. So this thing, this is a class. Okay, so if you are very new to computer science, then class is just, assume it like a template. So this is a template for this. Okay, this is a template for this thing. Okay, so it has two members. Okay, it consider just as a box which have two compartments. First compartment we will put the data, and the second compartment we will put the address of the next node, so it will pointing to that. Okay, that's in C++, they that's the thing, pointer in C++, but we in Python we use references. So the thing is that this node data structure, okay, has two partitions. First partition will hold data, and the next partition will hold the address of the next node. Okay, address of the next node. So you can just traverse this, and last guy will have the address of null. This is a null in C++, but none in Python. Okay, so let's code this. I have the blueprint of this, okay, and this is a constructor. They say constructor they call in C++, but in Python you must call this init method. Okay, so this is for initialization, and you will know its purpose when I will code further. This self thing is reference to okay, I will explain you when I do coding. Okay, what the significance of the self, because this is equally this in C++. Okay. So just remember for the time being that this is a template for this thing. So let's proceed. So we have this link node. Now what we have to define another class. Okay, is not okay, linked list. Now we want, okay, linked list, and okay, this is syntax. What we want init method again, so it will just initialize. The init method is like constructor. The Okay, I will just explain you. Don't worry, just be calm. Okay guys, so this got header, putting none. Okay, and I'm putting append method. Okay, I will all explain. Let me first write all this, guys. Okay, append, and okay, this will I will just put pass here, and this will the methods we will define today, and we will also discuss about recursion. Okay. Okay, but you will enjoy, guys, you will enjoy coding with me. So I just I'm putting this passes because I don't want to declare the definition now, because I want to first explain to you. So let's make this, we can always create the linked list by this, with this, bare bone. Let's manually create the linked list. Okay, so let me, open my paint, and I have this guy. Okay, so this is a head, and now head is none. Okay, because uh, okay, let me first do that. I want list. Okay, I want list, I want linked list. Okay, link the list. Okay, so what you are saying here, that you want a linked list, and you will have the reference of this linked list in this variable list. Okay, and it has, then after writing this, it will call this method implicitly. Okay, and what it does, okay, let me another put list 2 also, so you will actually get the, meaning of this self keyword. Okay, then I'm saying that list invoke, I want linked list. So what it will does, this self, this function will be called. Okay, and this function has this self parameter. Okay, then this self refers to this list. Okay, in this case, and refers to this, it refers to this, so self refers to this in this case. So I will go again. So this is, which object. Okay, so these are two different objects which have same templates. It's like, there are two houses which have same size, same structure. Okay, because they have the same template, you made them from the same template, but they are two different houses. So same concept. So self is needed to refer, you know you know for which object we are running this code. Okay, so this list has its own value of head, which will be none initially. So both list will have its head variables, and they both will have none. Okay, so let's do the, you will understand more clearly. So now I will just make this linked list nodes. Okay, I'm not writing any functions. I want to, first make this all things, uh, type manually, and then I want to make you understand. So it's very clear. It's linked list node, and I want value. Okay, let's put 2. Okay, and I want node 2. Okay, and I want node to be linked list node 3. Okay, and let's add this last node. I will call this node 3, and I will just say linked list node, and I will take 4 value. Okay, so now we will make first list. So let's comment here. So this is a commenting in Python. First, let's make the first list. Okay, first list, okay, let's make the first first list. Okay, that list. So let's, how you make, manually now. Just now what we have scenario, I will draw in a paint. Okay, so open the paint, and let's let's draw some crude diagrams to understand ourselves the concepts better. Okay, we have now, okay, I'll just remove this, I don't need this now. Okay, so let me think. This is, list 2. Okay, and this is, I guess, list 2. Not here, man, just I want here. Okay, so it will look better. Okay, I have list 2. Okay, and these nodes we have node 1, node 2, node 3. Okay, so let's draw them. Okay, so we will have this We have this, node 1 here, node 2 here, node 3 here. Its address is, let's say, 1000. Okay, because computer can give this address randomly, because we are not allocating continuously. It can be at the position 56. Okay, so I want to create the first list like this. Okay, so this head will point, okay, this list has the variable head. Okay, because when we create list we have head. Okay, so head is a kind of let me say attribute of this linked list class. Okay, it's its property, so it's variable. Okay, so in in very easy language I will explain like this. Let's say uh, uh, let's say human. Okay, human is an object. Okay, any human. Okay, Sharang. Okay, take me as an example. I'm a human. Okay, and Srirang is also human, John is also human. We share some common features. Okay, I have two eyes, Srirang has two eyes, John has two eyes. We have, you can identify us as humans. Okay, because you know what human means. Okay, so let's say that God has some template for the human. Okay, and he just creates objects. Okay, he created me, he created Srirang, he created John. Okay, and I have properties now I have this set of eyes, I have this nose, I have this tongue. Okay, I have this tongue. So John is also having tongue. John is having two pairs of eyes, John is also having nose. Okay, so now what property means. Okay, so human is a template, which God just reads out and creates human. And since he is using the same template for creating the human, each human has two eyes, one nose, and one tongue. Okay, and also Sharan can walk, John can walk, Srirang can walk. Okay, Sharan can eat, Srirang can eat, John can eat. Okay, Srirang can run, John can run, and Sharan can run. Okay, so these are their behaviors. Okay, and their behaviors can be kind of different. Usain Bolt is also a human, but he is very fast. Sharang is not that fast. And John can be slower than me. Okay, so now they have properties also and they have behaviors also. So the properties we have, we have for them, we just have this self dot head. Okay, so this node, sorry, this list. Okay, it is made by using this template. This list also made by using this template. This list has also the head, and this lid is also head, but and they are using this same constructor. Okay, that means whenever this statement is interpreted by Python, it will evoke this. So this list head is set to none, as well as this list's head is also set to none. Okay, very crude example that you must know the evaluation process, guys. And actually this is a true fact that in very initial days, no, some scientists observed the womb, that womb of 7 pregnant animals including human. So actually for the 7 days the development process was same. Okay, and okay, they have actually So they selected some animals, cows and mammals they selected, and dolphin also they selected. So for the first 7 days, the whatever cell division happened, no, it was same for all animals, and later they just evolved, using the DNA and all things. We won't go to that part, but they have initially same properties. So just remember that list has head, it is also set to none, and list 2 has head, it's also set to none. So let me go to the paint now. So the list has this variable head, and assigning it as none, that means it is not pointing to any of the nodes. Okay, but we want to make them now. Okay, so how we are going to do that? Okay, I want list 1 to start from here. Okay, then I will draw this crude diagrams, which are my specialty. Okay, this is first list. Okay, okay, okay. Oh, no, do that. Okay, no. Okay, it cannot just do this. Okay, let's. Okay, no. Okay. So let's use lines. Okay, so this will point to this, and this will point to this, and this will point to this. Okay, this will be our first list. Okay, and whatever values we have, this is node 1. Okay, this is node 2, this is node 3. So let me 2 3 4. Okay, those are the values now. Okay, I'll just put them here. Okay, this is 2, this is 3. Okay, come on, 3, this is 4. Okay, and this is our list. We want to do that. So now let's go into the code and let's create the list. Okay, let's do that. So first what we will do, we will just put list dot head, this dot head, we can access that to the node 1. Okay, node 1. Okay, then we will put node 1 dot next. Yes, okay, node 1. By the way, I just forgot to mention this. When this code is called, the structure will be like, when this code will call, it will be like, it will create this 2 with 2, this create with whole node with these 2 compartments. The first compartment which will hold the data that I'm gonna pass, this data, it will take, and it will create that node and it will put none. So initially they wasn't pointing, to anywhere. I later joined them. Okay, initially they weren't pointing to. Okay, this link wasn't established. Okay, this link was not there, but we want to build this linked list, therefore I have made this. Okay, so now let's go step by step. Manually will create linked list. So node 1 dot head will be list dot head will be node 1, and node 1 dot next, now I will set manually to the node 2. Okay, and what I will do node 2 dot next, which will be node 3. Okay, now we can print this list. Okay, how we are going to print this list now? So I will write while loop. Okay, so while loop, if you are very new to programming, okay, while loop just for looping. So what I will say that, I will just copy this temp. Okay, I will get this temporary variable and I will just put this list dot head. Okay, and I will say that temp, while temp is not none. Okay, what I want to do is that I want to print the temps data, and I want temp to go to the next node. Okay, so I will explain what is happening. So first what I'm doing is that first I am assigning this temporary variable now this temp guy is now also is here. So temp will point to this, this guy. Temp will point to, okay. Okay, now oh, what the, okay. Okay, well, temp will point to this now, okay, because I have set this temp to this list dot head. Okay, and while temp is not none, we have to print data, and we want to temp equal to temp next. Okay, so what we will do is that, okay, we will print the data at the temp, that is we will print 2. Okay, and then what we will do, we will be temp equal to temp dot next. So temp dot next is this, okay, and this is pointing to this. Okay, so temp will be now pointing to, instead of this, it will point to this. Okay, it will point to this now. Okay, and then it will just print the value here. Okay, and yeah, I printed 3, and temp will be temp dot next, that is this. Okay, so the temp will go here now. Temp will go here, so temp will now point to this. What it will do, it will just print the data of that guy, which is 4. Okay, and temp dot next be, is, we don't have, after this node we don't have anything here. Okay, so, and by constructor this thing is none. So now temp will be none, because after temp printing the temp's data, we are pointing temp to the temp equal to temp dot next. So temp will now point here, but since this is none, and our while loop will, will continue if temp is not none, but temp is none, it will break out. Okay, so so it will print 2 3 4. So let's test this code. Okay, I'm going very step by step actually. So let me first, PowerShell. Okay, I will just clear this. I don't use, man, this PyCharm and all this. Okay, we will have what the we have some errors as usual. So the thing is that I made a typo here. So I'm not using this PyCharm and all, because they are, very because I don't have installed them. I will do that, guys. So you can see that I will zoom this out. Okay, it's 2 3 4 and they have printed, but essentially we don't want to do this. If your manager comes to you, hey dude, I want 100 numbers, give me the it will give you list. Okay, it will give you list, and that list contains some 100 numbers, or you can put any data in linked list. You can put numbers, you can put names, you can put anything there. So this guy comes to and says that this is employee records, 100 employee records, and I want to make the linked list of 100 records. So you won't do this. No, this, if you go with this approach, then your work, it's very hectic, it's nonsense thing will happen. So we don't do that. Okay, guys, so we will code now. We will give this facilities. So we will, therefore we will define these behaviors, okay, which haven't defined now. I have just passed it. Okay, Python is very cool language. It's not like if you have declared define, no. It's like big, if you want to now, okay, you can, but if you don't want to, okay, just put pass and just go on. Okay, it's cool language. Therefore I've chosen Python for coding this all things. Okay, now let's clear this. We can also play with this list too, like this. Okay, but I won't repeat the concept. I think you grasp this concept. Okay, so let's automate this all process. So that for that I'm writing this append function now. So what I want to write in append function means just inserting at the end. That means what append will do, it will just I want to append this node. Okay, we have bad drawing. My bad drawings are getting very bad. Please consider it as 4. Okay, okay, it is 4. Okay, you are, please believe me, it's 4. So append function, what it will do, it will just create the, okay, it will just create the node. Okay, it will just create the, what I want this square. Okay, so it will just create node, and it will have some, it will have these compartments. One compartment will hold data, and one compartment, let's say this is number 6. Okay, oh, it's very good, I draw it correctly. So append function will just go to the end of the list, and it will just put next node. Okay, this is my next. If you append the node, then you will just append to this. So that's the meaning of the append. Okay, I will put 7 here. Now my drawing is getting very improved, guys. So let's code. Okay, so I will say that if self dot none, so actually my mom was calling me. So if self dot head. Okay, and Python, you have to just reference it. Okay, so it will know that which list you are talking about. Okay, therefore if self dot head is none, Python is like English. Self dot is none, then what you will do, you will assign, self dot head will be what, linked list node, and what you want, that whatever the data is passed to you guys. So yeah, means self I have to put here, and also I have to put data. Okay, and okay, I will put data here, guys. Okay, that will be fine. Else if you have some node there, then you have to go to the end of the linked list. So for that I will just put while temp dot next. No, first I will put this temp. Temp will be self dot head. Okay, self dot head, and okay, temp will be self dot head, and I will just do this while temp dot next is not none. Okay, is not none. So Python is English. While temp dot next is not none, what you want to do, temp equal to temp dot next. So you can just really readable language, and after entering the loop, that means you have reached the end of the list. What you have to do, that this temp dot next equal to linked list node data. Okay, that's all we want to do. Instead of going as creating 100 nodes and manually connecting them, we will do this. Okay, so tutorial is going very long. I won't define this function. I will just define this normal print function. So recursion we will see in next video, because it will be too heavy for you guys. Okay, so let's write print function. Okay, the thing is that it will also will take self thing. Okay, which is the reference to the list. Okay, I'm sure that you have got all these concepts now. Same thing I will do. I will just say if the self dot head is none, then just return. Okay, just return means go back to the, if you call here, no, if you have this, if you have this situation that head is pointing to the none, you don't have any data to print, therefore just return. Okay, return. And else what you will do, you will do this. Okay, you will take, this is, temporary reference to the self dot head, because we cannot manipulate this head, because its property. If we keep manipulating head, then we will, we will not have the reference to the first node, and we cannot let that happen. Therefore, for traversing, we are assigning this temp variable, so we don't alter the head value. Okay, guys. Identity of the linked list is its head node, because head node will point to the next node. Okay, so that's all the thing is there. Okay, so let's do that now. So it will be, temp will be, I guess, self dot head. So temp will be pointing where head is there. Okay, and then I will just write this loop while temp dot next. Okay, you will just sorry, you will just so what I'm doing. Okay, you can just play with this code, and you will just, instead of temp you can write temp dot next, but it won't print the last node. Okay, you can experiment it. Okay, and you will come to know all the intricacies of this programming. Okay, guys. So temp dot data, and temp will be temp dot next. Okay, so that's it. That's all we want. Okay, that's all we want. So now your boss comes. Okay, now your boss comes. Boss says, I want, 100 numbers in a linked list. So you say, okay boss, here you go. You will just go like this. You will firstly clear the list. Okay, and it will be linked list. Okay, and yep, and then you will just write for loop. Okay, this is not the layout of our I in range. What you want, boss? You want 100 numbers. Okay, here you go. Okay, so 1 to 100 number you want, then just remember this syntax. This range will give you 1 to 100 numbers. Okay, and what you want to do with that, boss? Okay, I will just, boss says, append to them. Okay, so let's append them. Okay, append I, so it will call this function. Okay, here you don't write to you will write self here. Okay, it is, you must write here always. Okay, and you will just call print. Okay, yeah, list dot print, actually list dot print. Okay, and it will just if my code is right, if I didn't made any mistake, then it will run fine. Okay, then let's put this code to the test. Okay, where is that guy gone? Okay, I think I removed him. Okay, here. So to open this, okay, what I'm doing, I have to put shift and left mouse, sorry, right mouse key, and open this here, and I will just write command python, and it will just like dot. Okay, it will like linked something. Oh, tab. Okay, what that, dot slash linked. Yeah, I don't want that. Okay, what happened now? Okay, interesting. It doesn't, okay, I will just remove this. Okay. What does can't open file? Okay, let me get to the back, guys. Okay, why it's not compiling, man? What did pi? Okay, okay, that was okay. What the error is there? What is saying? Invalid syntax is not none. Okay, I got it, where I gone wrong. Okay, sometimes I do these typical mistakes, which are, kind of my habit. Okay, so just please bear with me guys. Okay, yeah, it printed these numbers. Okay, I will show you them. 1 to 99 it printed. Okay, but I wanted 1 to 100. Okay, so what I will do, I will modify this range function. Okay, because this range has particular peculiar characteristic that it will go from this number in steps of this to reach this number. Okay, you can just I will explain in later videos what range does. Okay, but for understanding it will just give you numbers 1 to 100. Okay, that will be fine for understanding. So let's do again. First we will clear this all things. Okay, I again typed wrong. I do all this things. Okay, you can see that these are 100. Okay, I think you can see now. So that's the end of the today's tutorial guys. I will go in depth of the linked list tomorrow. Maybe I am starting this data structure series for very beginners guys. If you are very kind of just want the code in Python, then I will just post that code in github repository. Okay, you need not watch this video. This is our for beginners. Okay, so with that I will just close this video guys. So please like, subscribe, share as you do always, and support me. Okay, so this is Sharang signing off. Bye.